I would like to welcome everybody to the MyCS PhD information session on what is research. The goal of these sessions in general is that we want students to make as informed decisions as possible about whether they should pursue a PhD. But another goal is that we want to even the playing field so that students, maybe from less likely places, also have all the information they need to decide whether to pursue a PhD, to apply and have a good chance of getting accepted and all those things. And the particular goal of this session is to maybe remove some of the myths about research and what it means to do research. And so we have, let's see. All right, actually, there's some of the things I just said. But we find that students who have more information, not surprisingly, make good decisions about whether they should do research, whether they should do research, whether they should do a PhD, where they should do a PhD, who they should work with, etc. So here's how it's going to work. Some of you have already submitted a bunch of questions. We are going to go to Slido. I'm actually going to show a Slido page. But you need to also be on Slido if you want to add questions, if you want to vote up questions. So look for questions that maybe are similar to what you might have asked and vote it up. If not, then add your question and let other people vote it up. And we're basically going to be answering questions in terms of popularity with some balancing of topics. And obviously we were looking at sort of appropriateness for this forum as opposed to other forums that we are having as well. All right, so here are our panelists, and I'm going to let them introduce themselves. I'll go ahead and go last, and so we'll just go in the order here. And so what I want each of the panelists to do is just tell us real quickly who you are, what your research area is, where you are, and then give us your 2-minute spiel on what you think research is. And so let's just start at the top with Ada.
Thank you. I'm Ada Gavrilovska, and I'm an associate professor at Georgia Tech in Atlanta. My research area is systems. I have been at Georgia Tech for a very long time. My first time came at Georgia Tech as a visiting undergrad, and then I came as a master's student with the intention of moving to Europe for my PhD, stayed for my PhD, and stayed in various roles before transitioning to a tenure track professor role for various various personal reasons. But I've been at Georgia Tech for a long time. I like the question, what is research? So there are many kinds of activities that you end up doing while doing research, particularly in computer science. You write code, you debug, you make figures, you write papers, you write slides. And so kind of how do you know that when you are doing those activities, you're actually doing research? John Wilkes, who's now at Google, has been giving this awesome talk, very animated, the purpose of the talk is around how to write an abstract, how to write a poster, how to give a short presentation. And the high-level message of kind of his animated talk is that you really need to answer 4 questions. What is the problem you're working on? Who cares about this problem? How is it that you're solving it in some unique way? And why should somebody care for your solution? And so like in that sense, if you try to go from those points to what is research, you're doing something, you're doing all those activities that I mentioned, but you're doing them with the goal of solving some problem that somebody cares for, not just you, but somebody that you can articulate kind of who has this problem. And there's some novel angle in your solution, at least, hopefully it's very revolutionary novel, and that you can quantify and measure the benefits that your solution brings in some way, so as to convince people that, this is to explain why it is that they need to use your solution. So doing all of those things, I think that ultimately that qualifies as your coding for research. and making slides for research.
Great. Thanks, Ada. Chandra, how about you?
Hi, all. Thanks for inviting me. I'm very happy to be here. I am a professor in computer science at UC Santa Barbara, but I did my master's and PhD at UC San Diego, where Professor Tulson is. I work in the area of programming systems for distributed deployments of devices like sensors if you've heard of the Internet of Things, and how those systems bridge to larger computers called clouds. So I look into things, problems that work on how do you program systems like that? How do you make them easier to use and more fault resilient? And for the question, what is research? To me, it's simply, it's creating new knowledge. And you can do that in all kinds of ways. As Ada said, you can do it through coding, you can do it through thinking, you can do it through mathematical proofs. In computing, there's so many different ways that you can pursue research. You can do anything from creating whole new devices and technologies, hardware and software. You can come up with new ways of solving problems that are better than what came before. But it's all about producing new knowledge, finding a problem and coming up with a unique solution and convincing others that it's worth solving. And so, yeah, I'll just stop there.
Great, thanks, Chandra. Jack, how about you?
Hi, I'm Jack Sampson. I'm an associate professor at University Penn State. Let's get a short version of it, not the long one. I did my PhD at UCSD, so some of these folks on the panel have seen me before. My area of research interest is broadly computer architecture, and more specifically looking at how computer architecture interacts with emerging technologies with a sub-focus on energy efficiency in particular. Research is the constructive mitigation of a fundamental dissatisfaction with either or both of the state of reality or our knowledge thereof. Right, so there's my one sentence version, as long as that sentence may have been. More broadly, to dive into that, it's constructive in that you want to do something about the fact that either the way that we're doing things now is insufficient for what you want, or that you believe that there is a better way that we could be doing, that there are opportunities. And in either of these cases, you want to move our sort of notion of where the state of the art is from one place to another. Now, unlike in the sciences in general, where there sort of is an assumption of objective reality and we're just going to discover more things about it, the computing sciences are an engineering field. And so what we're discovering, if we're trying to get better understanding, is as often as not about the sort of almost an anthropological question of the human-created artifacts that we're using for computing. Then we're building a better model of understanding of how things actually work, or the models that we're using and their implications. But more often when we think of a lot of the things as research in engineering, we're saying we believe you should be somewhere else, but there's so many possible places that you could go that, as other speakers have alluded to, there's a fundamentally persuasive element in arguing that not only should we be somewhere else, but among all the many different ways that things could be, this is the one that you should be paying attention to, the one that you are advocating for. So that's my short version on research from philosophy to computer science.
All right, thanks, Jack. All right, Rachel.
Hi, I'm Rachel Pottinger. I'm an associate professor at the University of British Columbia. That is in Canada, but I got all my degrees in the United States. I'm also a member of the Computing Research Association CRA board. My research area is databases and data management, particularly helping users understand and explore their data. Everyone else has some really great definitions of research. I was really enjoying listening to those. I'm going pretty late in the list, so I'm just going to keep it short. In my opinion, research is the discovery of new knowledge. Basically, it's exploring things that haven't been explored before. As others have said, in computer science, this often means things like creating new algorithms, figuring out the complexity of problems, or building things such as systems and testing them in one way or another.
Great. Thanks, Rachel. Vijay, how about you?
Hey folks, thank you for inviting me here. I'm Vijay Chidambaram. I'm an assistant professor at UT Austin. I work on storage systems, all things related to storage. So my group, the motto for our group is we are helping build the next generation of storage systems. That's what we like to think we're doing. Regarding like what is storage, what is research, I'd like to keep it very short. It's answering some question. So some question that you sort of like, you don't know the answer to, or figuring out how to think better about any particular topic. For example, in one of my recent work, the question we were trying to answer was, does storage matter when you're doing machine learning? So, and then we found out like, oh yes, it matters, and like this is how it matters, and so on. So, so usually it starts with a question. That's how I like to think about it.
Great. Thanks, Vijay. Okay, and then last, I'm Dean Tolson. I'm a professor at UC San Diego. Got my bachelor's and master's from UCLA. Then I went out and did computer architecture out in the real world, then went back and got my PhD at University of Washington. And I do research in computer architecture, lots of history doing stuff in multi-core, multi-threaded, things like that. So lots of parallelism. Now it's almost all the interaction of computer architecture and security. And again, one of the goals of this panel is not to say a lot of redundant things, and therefore I'm going to model that similar to the last two, but even more so, I'm not even going to answer the what is research question. So let's go to some of your questions. And so now I'm going to have to stop sharing this. I'm going to go to the Slido page. Hopefully people have found that. All right. Okay, so hopefully everybody can see that. And so we are going to, so our moderator, Kazim Taram, thanks Kazim, is going to help us. And so the first question was, what is computer science research? I believe we have answered that now. And so let's just go to that next question, which is, do I need to know what I'm going to do research in before I get to grad school? Anybody want to take a shot at that? Rachel?
Sure. So I would say, and I note that there are differences in getting admitted to grad school in the US and Canada, but by and large, you don't need to know what you want to do before you go to grad school. What you do need is you need the ability to tell a good story. So you need the ability for people to understand that you know what research is. It's totally fine if what you say you're interested in is not what you wind up doing, but you need to be able to show that you have some idea about the process of doing research and what that looks like.
That's good. One thing that I think is really helpful to understand, though, and just to add to the part about telling a good story, is that at most places, your admissions differs, but at most places, you are admitted into a research group more than you're admitted to a department or a school, which means that somebody has to believe that you want to do research in their area and work with them. And so at some point, somebody needs to read your research statement and think, this person's a good match for my group. And so to that extent, you need to be able to sort of describe what you want to do. And if you end up doing something different and working with somebody else, that's okay. But at some point, somebody has to sort of believe that you're a good match for the work they do. I think at most places.
If we can just add on to that. If you're taking undergrad classes, research is very different from just taking classes and doing well in them. So the reason we sort of like stress on have you done research is because before committing like 5 years at least of your life to doing a PhD, you want to make sure that you've done research, then you like it, right? Because like a lot of people really like classes, but research is very not structured, and a lot of people have trouble with that. So you want to make sure that you've done research and you like the process of doing research.
So in a related question, I think that follows from that, right? So how do you figure out what area and what topic to do research? I actually believe those are radically different questions, right? The process of determining what area you want to work in versus what your dissertation topic is going to be. So maybe we can split those up. Anybody want to start with area, how I decide, what area I should target?
So I have a very simple first order model when, for instance, honors students come by for advising and they ask me about, potentially applying to grad school. I say, okay, I draw a Venn diagram. It's got 3 circles. And one circle is things that you're interested in. One of the other circle is things that anyone else is interested in. And then the third circle is what can you actually do, right? So, you know, it would be good to be interested in things that you can convince anyone else that they, to actually help you work on, right? So if there's no overlap between what anyone else is interested in, then it's going to be very difficult to find advising and support. And if you can't do it, well, you can grow that area. That's the most fungible in some sense. Well, I mean, your own interests are fungible too. I'll circle back around to that. But if you don't at least have the ability to begin, then it's not necessarily a great topic. So if you find yourself borderline enumerate, probably cryptography is not for you. Right? You might want to go towards your strengths and your own skill set. But in terms of your own interests, I find the biggest question there is, to the degree that the undergraduate education is not research focused, you may not know what you're actually fully interested in. So you're merely making a prediction about your own tastes fairly early on. And so I find the best way to try to figure that out is to have conversations with people about what the actual sort of living state of an area is, and understand if that actually is something you really want to be part of. And then you optimize for the intersection of that Venn diagram.
Okay, thanks. Thanks, Jack. So arriving at a topic, right, that you're going to do your dissertation on, or maybe even your first paper on, is, I think, a very different process. Anybody want to, and not something you have to do before you go to grad school, but anybody want to sort of touch on that process?
So I wanted to go back a little bit on the area and to point out one thing that's sort of one positive outcome of the current pandemic situation is that a lot of the conferences have nearly instantaneous availability of sort of short version, very short version of talks, and longer version of talks, and so forth, and full version of talks. And I think it can be quite useful for students to also sample a little bit of what is going on in an area, what are the kinds of things that people are looking at by looking at some of the top conferences across the different areas. And particularly given that maybe some impromptu interactions and conversations about what people are doing are more difficult right now, this can be helpful.
So just to add on to that a little bit, so to figure out what area to work in, what's the undergrad class you like best? Go talk to the professor, and sort of like that's a good starting point. If you didn't particularly enjoy any of your undergrad classes, which professor did you like best? Go talk to them, and they'll be able to sort of like point you to things. So I think one thing that sort of like undergrads problematically focus on is area and topic. In my mind, this is not important at all. I think what is important is figuring out what you like to do and like the people you want to do it with. So most people can get interested in a variety of topics, but you need to have like a good fit between like, like your advisor and yourself. And so that is much more important.
Great. Thanks everybody. One thing that I've sort of changed quite a bit in the way I sort of think about research topics and students in particular is that I find passion is just so important, right? So a really, really amazing student who's not passionate about the research topic usually flops, and a less capable student that's passionate is going to succeed. So find your passion.
Yeah, I love all that. I just want to comment on the second part of the question, finding a topic. It's really going to build off of what Vijay just said. So you do this once you are in a PhD program. Let me just make that clear. You want to, what everyone else has said is a really good advice for as you're trying to figure out what places to apply to. But once you're at a research place and pursuing a PhD and looking for a research area and an advisor, sometimes you're in a group, sometimes you're not, but either way, it's really good to explore. The beginning year, the first year at least, is your time to just sample different research areas. You can take classes and see, you want to see different areas. You want to see things that are challenging for you, things that are easy for you. You need to stretch. In some cases, you need to find personalities of faculty that work for you in terms of work style. So there's this really discovery process that you go through in your first year. as you become, as you commit to a particular research advisor and to a particular area, and the advisor then helps you refine your thinking so that you can settle on a topic. So that's all part of the education process in a PhD. We help you with that.
Great, thanks. Let's go ahead and move on. What's the difference between research in industry versus research in academia?
I'll nominate Vijay to answer that question.
All right, so I spent like a year in industry before I joined academia. Maybe that's why I'm nominated for this. But I'd say that like the big difference is one, like, depending upon the lab you're in, there are certain topics that you could work on and certain topics you can't work on. And in academia, that's not the case at all. You can work on anything that you want as long as you can get some funding for it. And if your advisor gets funding, like, you don't have to do that today. So you have a lot more freedom in academia on like what topics to work on. And there are questions that are like, more of interest to academics, but not really to sort of like people in the real world. You could still work on that in academia. Whereas if you go to industry and you're like, like you want to work on something extremely theoretical, it may not be like a good fit for the lab. Other than that, I think in industry, if you're working as a researcher, you interact with other researchers. So you don't interact with students as much. You do get interns, but like only in the summer. Whereas in academia, it's all about students, right? You can only do so much yourself. So really, like, research in academia is the joy of like, helping students figure out how to do research and sort of like enjoying that versus doing research sort of like yourself. So that's I think the biggest difference of students between these two.
Rachel?
Yeah, I just wanted to add that I think that that's a really good summarization. I haven't been in industry myself, but I did do a number of internships at a number of places. And one thing that I think that is very different between academia and industry is that in industry, one of the pros, unlike the cons as far as I'm concerned of not having students, is that you have access to all sorts of interesting problems and data and people, right? So you have a whole bunch of people who are solving the same kind of problem. In academia, there's generally a smaller number of people working on the same problem. So you tend to sort of skew towards different styles of problems potentially.
Right. And one other difference in the ideal world, at least, is that industry tends to look at questions that are one turn down the road. And hopefully academia has the freedom to look at something that's 5 turns down the road and look further out ahead, because industry just can't afford to do that because they have to work on things that are going to impact the next generation of products.
And to just really brief follow on to that, my experience in working with industrial collaborators, another way to sort of look at that is not necessarily timeline per se, but the degree of focus on quantitative versus qualitative changes. Right. So there's a very particular set of metrics that industry usually is interested in hitting. Whereas on an academic undertaking, the fact that it's fundamentally different, even just understanding how something different might work, is value in and of itself.
Okay, so the next question I'm seeing is, how can I tell if research is something I'd like? That's actually a really interesting question.
I can start with this one. This is a great question. I think the way to do this is to explore and to talk to others. So there's multiple ways of doing that I recommend. And that is, as Vijay said earlier, find a class and that topic that you like and go talk to the professor. Ask that professor, what was research like for them? What is research like for them if they pursue it today? And what their views are. Join a research group. Explore, do a small project with maybe 1 or maybe 2 different professors to get a feel for problem solving and working with someone in a group that's outside of class, because it's very different from the structured undergraduate classes that most of us teach. And then lastly is to find students who have pursued research with an advisor or a professor and ask how they feel about it, what they think about it, how it went for them, what they liked, what they didn't like. And you'll learn a lot about what works for you. The key thing that I think that people miss when they're thinking about research or pursuing computer science beyond your undergraduate is research is not structured. Research has no answer for many of these things. These are hard problems, and we don't know how long the problem is going to take to be solved. That unknown makes some people uncomfortable. Sometimes, it's just makes you anxious if you don't know how long this is going to take. If you're really used to having a course on a cadence where you're producing labs and homeworks and finals and getting the grade and moving on, that's nothing like what research is. Research is really open. It's really wide. It's really meandering. It has ups and downs. And you kind of have to feel what that feels like to see if you're going to be okay with that. Now, we help you learn how to be okay with that, but you can start to explore that in your undergrad to see if research is going to be something for you.
So I'll comment on a slightly different tangent from that question. One of the challenges in telling whether or not research is something that you'll like is that your individual research experience, the variance is high, is another sort of way of looking at it. And a lot of that can even just come from whether or not your particular path that you took and the people you happen to be working with all clicked. There's a fundamental element of luck and circumstance of human resources in the research experience that's difficult to even tell you whether or not you're going to like it, even if you have sampled it, right? So you might be that you liked doing research with the people at your undergraduate institution, and then your experience when you went to another institution was not the same. But I get, here's what I'll tell you to that. If you like doing research with anyone, then there exists some place somewhere where you will probably like doing research. Yeah, short of just doing it, I'll just hark back to the questions about uncertainty and open-endedness, and then you can. The closest model I can do to tell you to sort of try to test yourself without just sampling is, ask yourself whether or not you like solving problems that you're not required to. Right? That's one place to start, at least.
Actually, I'd like to turn this question on its head a little bit, and I think Jack already started doing that. For the panelists, assume that either a student in a class or that you interact in some other way, and you look at that student and said she would make an amazing researcher, right? What are the qualities you saw in that student that made you say that?
For me, it's curiosity. If the student asks questions beyond what we're talking about, digs deeper, wants to know more, is just hungry for more knowledge, for more information, I think that's a really good sign that they'd be a good researcher.
Thanks. Yeah, that was a great answer. I'm going to skip over one. So how much freedom do you have in choosing your research topic? So this is similar to something we've addressed before, but let's put this in an environment where you're already at a school, you're working with an advisor. In that context, how much freedom do you have in choosing a research topic?
I can go first, I guess. This varies from lab to lab and from professor to professor. So I can tell you what happens in my group. So when a student joins, right, like the first year in my group is basically their learning session, put it one way, right? So they'll be paired with a senior student and they're learning the ropes of research, basically, to figure out what to do. At that point of time, there's no expectation that they have their own sort of like topic that they want to pursue. It's just that they're learning the ropes, like figuring out how to do research and so on. From the second year onwards, like they're sort of like, oh, like I've read all these papers, I've attended a conference, hopefully. This is the area that I would like to focus on. And I sort of like, I work with the student to figure out what is an interesting question that you can tackle in that topic. And the first sort of like project in Duke is very hands-on, right? Like both of us working together very closely. But as they grow more senior in their PhD, they get more and more sort of like freedom. Sort of like by the time they're ready to graduate, they'll be like, I'm going to work on this, and this is how I'm going to do it. And I'm like, yeah, let's do it. And like, that's how I do. So that's how I know they're ready to graduate. So over time, they get more senior. They're able to pick their own questions, figure out how to handle it, and so on. But early on, when you're sort of more junior, You may have like a vague understanding of the area you want to work on, but your professor will help you sort of figure out what's a question you can tackle inside that.
I think that one challenge is there are some research groups where kind of what happens in the group is heavily influenced by funding. And so in some sense, I think advisors love it when students initiate problems, initiate topics. Sometimes there is this balancing act. I think that there is a benefit there because if there's funding on the other end, that means that it's very clear who is kind of who is the customer, who is it that you would like to convince, we would need to convince that there are problems that you can address. So it can in some ways help you sort of scope some of the evaluation metrics, some of the positioning of the work. But that could be one limitation in some cases.
Yeah, funding actually can influence this a lot, right? Because if you go and work with somebody who has a $20 million five-year grant on X, you're going to work on X. But a lot of people have much more flexible funding models where if you have an interesting problem, go work on it, right? But that's a subtlety that most PhD students applying to PhD don't really get. We don't expect them to, but you know, if you really want to ace this thing, you know, that's useful information. So a really interesting question. I'm going to skip over this one again because the next question is really interesting. So what do you do with a PhD besides just do more research after your PhD? What do you do after your PhD?
I'll actually tell a quick anecdote about a friend of mine who was working in the Google search group, and about half the people there had PhDs and half of them did not. And he said that you know, after they'd been there a couple of years and everyone was more or less equally up to date on the code base, the fundamental difference was that the PhDs were much better at persuading other people and communicating, you know, why we should go in a particular direction. But the skill set in terms of actually doing it was all about the same. So the ability to articulate, you know, the set of changes that you think should occur is a good skill no matter where you end up in your life.
I'd like to add something along those lines. Jack, you really triggered a good topic here. Also, I think besides just being a professor or a teacher, teaching is fabulous and you can pursue that. But the other thing that a PhD helps you with that I think people overlook is being an entrepreneur. If you think that you want to start your own company, the PhD really lays the foundation for you to go and attempt starting your own company. You have to go into the unknown. You, as Ada was saying earlier, you have to find your customer. Who are you solving the problem for? All of that can be brought to bear on creating a company of your own. And you know, some schools emphasize entrepreneurial activity or have options for you to pursue those tracks. We do at UC Santa Barbara. That is definitely something that all the PhDs that I know who've gone on to do startup companies, you know, they still, not all startup companies work, but they all are really well equipped to be leaders in those companies.
Yeah, I think one of the myths, right, is we obviously send some of our graduates to academia where they do more research. We do examples we're very proud of, right here, Chandra and Jack. But the majority of our students don't go into academia, or our PhD graduates. They go to research labs. Some start their own companies. Some go to companies that don't really have research labs, like, you know, Google and Facebook and things like that, where they kind of just are in kind of technical leadership positions early. So there's a lot of options, and you know, I've had graduate students who just have an amazing flair for research. I wanted them to go into academia, but they really liked just building real stuff, and so they said no, and you know, with the industry. So you can do a bunch of different things. And in fact, the majority don't end up sort of staying in academia all their lives.
Yeah, just to, or actually, like, Rachel, did you want to add something? Like, you have your hand up. I'll go after you.
Yeah, no, so I was just going to say that I think that for my students who have gotten PhDs and have gone on to industry, I've had a number who have gone to industry as opposed to industrial research. And what they found is that having a PhD gives them more of a chance to sort of steer the direction of where things are going, because they know how to go out, even if it's not in what they've done their PhD on, but it gives them a chance to say, oh, so if we're interested in going this direction, I know how to go and follow the literature and see if what we're doing makes sense, or see if there's another approach. So it helps people to be able to steer.
Yeah, just to emphasize what Rachel said, right? Like, I think what a PhD really does is it allows you to be comfortable with ambiguity, because you're working in this really unstructured space for like 5 years. You no longer need a very well-defined problem to be given to you. Somebody can tell you something very vague, which is what you do as you become higher and higher up in a company, right? Like, nobody's going to tell you exactly how to increase your profits by 20 million next quarter. You have to figure out how to do it. And so the PhD sort of like lets you do that very nicely. And that's a big difference that I've seen between people who have done that. Another thing I want to emphasize is that most PhDs do not actually work on something related to what they did their PhD in. Like if I went to industry, I don't think I'd be working in like storage, for example, right? But the skills I get during the PhD are still valuable even in other contexts.
Okay, great. So the next question is about, I think somebody who got their undergraduate degree but's been working for a while. Does that help them get into graduate school? Does that make them more qualified for graduate school? What would you say to somebody who's been out working for a while? Rachel's got her hand up again.
So I think that the way that I would think about this is that there are two differences. And one of them is really how well you're going to succeed once you're in a PhD program. And that I'd say you're probably well suited, because more mature students tend to do well. Getting in, the biggest problem that I find is if you have trouble getting the right kinds of letters of recommendation, right? Because the letters of recommendation that we get from people who don't have PhDs often focus on the wrong things. So they don't talk about, this is the kind of research that this person has done, or here are the kinds of skills that this person is going to say. They're going to be like, yes, this person is great at, getting X, Y, and Z done. And that's something that is not necessarily the right thing. So the right thing to do, if you are in this situation, is to think, okay, where can I get a good letter of recommendation? Is there a local university where I can drop by and perhaps join a reading group? I've had students do this and this has worked out well for them. Or is there someone in my organization who has a PhD who I can talk with, who can help me navigate this? If you are a student who is an undergraduate, or you still have ties to your undergraduate institution, but you might want to get a PhD in the future, it's a really good idea to talk to one of the people who you're connected with research-wise and say, hey, I think that in a couple of years, I might want to do a PhD. Would you be willing to write a letter for me at that point? And then I will go ahead and write a letter and stick it in my files so that when that person comes back, I have it all ready to go.
Ada.
I actually have a case just like that, a new student that will be joining my group out of undergrad, 8-9 years. He happened to have spent time at Google most of this time. So last summer, he approached a research group at another university and said he has time, he's interested, whether they'd be willing to take a visiting researcher. I think from a skills perspective, as Rachel said, having 8 years of industry experience, you're definitely not taking a risk there in terms of, is this person going to be productive with the things that I will tell them, right? So the student already had some output from that research relationship. And the other thing that they had done within the organization that they work, so at Google, all of the companies have some type of outreach activity where they interact with academic environments. So he had been in a group that he was involved with, some mentoring of students and even some instruction at another university. But that gave him a source of another kind of letter that let us evaluate the student a little bit more broadly beyond just the engineering performance. To go back to something that Dean said earlier, at Georgia Tech at least, although you can always champion a student, we review as an entire area the student. So it's not necessarily that we're looking for a match for an individual group, but wanting to make sure that there is a bigger buy-in. There are a lot of unknowns. There's a personality match that needs to be there. And so we want to make sure that there is a bigger buy-in. And so this particular student, there were multiple people that were very supportive, and the letters let us do that, or let us evaluate him like that.
The next question, I'm going to see if somebody can sort of maybe handle this quickly. What do you think distinguishes CS research from, I'm not sure what traditional science is, but other areas of research?
So I think I briefly spoke, well, I said a lot of words in my definition of what research was, but there are all sorts of various quips about, that computer science isn't a science, and it's neither applied math nor fully engineering, but the engineering of systems to do applied math at some level. And so I think the key issue I would say here is, as an engineering discipline in general, the necessity for persuading people that the question and the solution that you're pushing on have any value at all is important, in a way that discovering something about the fundamental nature of the universe, even if it turns out to be not useful, is still something we didn't know before. But discovering something about a man-made artifact, there's a difference in terms of getting the buy-in that people actually care about your problem. So I don't know if that was the type of answer that people were looking for to that question. That's fine.
Okay.
I'll say something a little bit different than that. Maybe on the more positive note, I think there's a huge opportunity in CS research that's different from other sciences, and that's that we have changed the world in the last decade or two, and you have the opportunity to go in and work on problems that can directly have an impact, a near immediate impact on the world around you, on society, on different problems. Now, not all computer science has that impact. Sometimes that impact takes longer to get out to society, but there's a lot of computer science where you can have that immediate impact, and that's very exciting and I think compelling.
So let me actually sort of bounce back, and so I agree with your positive, but I will also say that's the rate of change of computer science research is not 100% a positive, insofar as even understanding where the state of the art is a radically moving target, which means that even understanding whether or not the things that you're really interested in solving are the state of the art can require a very active reading habit in a way that perhaps I don't want to say other fields are not slower. It's only because it's relative, right? But if there are 10,000 submissions per year to ICML, no one is actually has read all of them, right? In a way that you might actually really be up to date on whatever the current annealing process for steel making is.
Yeah, I'm gonna give again a more positive slant on Jack's answer, because the rate of change is good. Why? Because the world is completely different than when I started my faculty career, right? And there are new problems to solve. And every couple of years, I get new problems to solve, right? Because, if you are in, studying Shakespearean literature, the problems you're looking at, the questions, if you can find any that they're there at the beginning of your career, are the same ones at the end of your career, and nothing has changed. Whereas every 2 years in computer architecture, we're starting with a clean slate and solving new problems. And that's fun. It makes research easier. Okay.
Yeah, I don't mean to be negative. I just I like to look at a couple of different sides of things.
No, absolutely.
And I think the fact that there is a set of trade-offs makes it meaningful what we end up choosing to work on, perhaps, right? of all those topics that we could be working on, right? As we're not working on the one remaining thing that's left on Shakespeare. I think that flexibility and having to find something that we can convince other people of is ultimately a net good if you clear that one little hurdle.
Great, thanks. Let's move on to another question. I'm afraid we're going to get too philosophical with this top question. I got to go to the next one. If you're working in an industry and you want to get some research experience, maybe with the goal of then having a better CV for applying for a PhD, what would you do? What would you tell somebody that's in industry and maybe looking a little further down the road to applying to PhD? How they can get research experience now?
So I gave concrete examples based on a real case and what worked. The student identified a research group that they approached based on a university that they were familiar with, and so you have to start somewhere. Probably sending a message to a superstar faculty member that has a huge research group. They probably will just not have time to engage you. But so starting with a smaller place, that could work. And then if there are some opportunities in the company, that as well could provide some opportunities. If you have an option to get engaged with interns, I think one of the ways that I've gotten involved with industry engineers who ended up doing research in the process was through internships. So if you have a way to interact with some of the interns that are in the company, and in that way, interns love figuring out how to convert their internship in a longer project. And so that can give an opportunity how to do that. I'm not sure kind of whether in a concrete company seniority matters on whether you're allowed to do that or not.
Rachel?
So I would say that there are two different answers, and one depends on if that time is now, and the other depends on if it's in normal times. So I'm going to go with the normal times first, because I hope that we're going back there, which is that in normal times, universities have talks. We have talks all the time. And the easiest possible way to understand what's going on at that university is to look at their talks, and then if at all possible, to go to those talks. Because if you go to the talks and then you have a chance to talk with people afterwards, then that will get you a chance to know a little bit more about the community there, and you can ask questions, and it's a chance to really sort of see what's going on there, as well as to ask the questions to someone in person. Because what you really need is you need someone to give you a chance. And it's going to be easier if you have a chance to talk with people. So that's the steady state answer. The answer for now is the answer that someone, and I apologize because I've forgotten who said, which is to look at the conferences, because there are an awful lot of conferences that are on right now. And all of these conferences are trying to figure out how they can do social interactions. So look in the area that you are interested in, look at the talks, see if there are people who you can get involved with that way, if they have some sort of social interaction, and get yourself involved there. But by and large, it's just going to take putting yourself forward, whether it's virtually or physically.
So this next question might be a little bit off topic for this one, but it's also talking very much to our target audience, which is people maybe who don't interact regularly with faculty that advise a lot of PhD students. So you come from a place where there's not a lot of research going on. How do you find potential advisors, people that you might work well with and it would enjoy working on the research topics? Who has ideas there?
I can start. I would say if you're applying to grad school, I would look for a place that some of the other panelists have hinted at, that have multiple people in one or two of the areas that you're most interested in. because that will give you, that will let you have choice when you get there. Now, some universities are going to pick you and you will be put into a research group, typically with more than one faculty. So you'll have some choice there and you can always move around. This is just a good way to get you started. But I always like to see for someone who is not sure or doesn't have like a strong relationship already with one of the faculty, you don't have to know who you're going to work with before you apply. And once you get there, then you can explore. You can take classes from them. I think Ada hinted at this. It's not just the research area or the topics that a professor works in. You need to know whether you like their work style and how they interact and treat their students. That has to work for you as well. So it's a discovery. And that I said earlier, that first year is really designed to help you with that discovery process.
Yeah, and don't underestimate the importance of reading papers, right? Reading papers is so important to this process, right? If you're not reading research papers and you don't kind of enjoy reading research papers, even if they're hard, when you're undergraduate and don't have as much background, if you don't enjoy that, then maybe you should be thinking twice about doing a PhD. But so read papers in the area you're interested in, and you're going to read a paper and say, "Wow, that was an amazing paper." Well, look who the faculty members are on that paper and contact them. That's a good place to start. All right, so there's an interesting question. Again, a little off topic, but I really want to answer this question. So everybody says I should work in machine learning, right? And so I don't know about the other panelists, but I'm going to tell you no, right? So if you're interested in machine learning and X, right? Even if you're equally interested or even more interested in machine learning, work at X, right? So here's the math, right? 80 to 90% of our applications for a PhD are in AI and machine learning. 20% of our faculty are in AI and machine learning. So do the math. It is really, really, really hard to get accepted to do AI for a PhD right now. So if you're interested in something besides machine learning, pursue that interest. Anybody want to disagree with me?
Right. I want to add one more thing beyond that even if you manage to get accepted, right? Imagine that you've gotten accepted to do machine learning research that you don't really want to do, or at the least you would not prefer to be doing. You'd rather be doing something else. Given the way that both the research process and graduate school in particular works, the odds are your efficiency is not going to be great and you're not going to be happy, right? You really, really want to, your best case scenario, right, is that you end up working on a topic where you find yourself thinking about research, in the shower, at dinner. I mean, I don't want to, say like some addiction that takes over your life or something, but no, the ideas should come to you because you want to spend time on them. And if you don't want to spend time on them, given that the scope of many of these problems is ill-defined, you won't, right? So if you really want to make progress on research problems, you want to have a research career, you should be doing it on something that you like doing. If you're punch clocking, your way through research, it's going to be a miserable slog. So follow your heart, please. I think everyone involved will be happier.
And that's not to say we're advising you to ignore machine learning, right?
Right.
There is an if. There's an if there in the beginning, right? So if you want to do machine learning, please do machine learning. The answer is you should follow your heart wherever it. You should do what you have passion for. As Dean said earlier, right? The importance of having some passion about a topic. You should care about your research taste. I mean, again, think about it. As I've said before, there's this persuasive aspect of it. Right? So you're persuading people of all the things they could be spending their time, energy, and effort doing. They should be looking at this particular way to change the world and solve the problem that you're telling them they should be paying attention to in the way that you're asking them to solve it. And if you want to make that argument for something you don't actually care about, I mean, that's rough. At best, it's rough, and at worst, it's disingenuous, which, and neither of those is a great way to be living.
Machine learning does not operate on air, right? I mean, machine learning is awesome, but then machine learning requires architecture, systems, compilers. There's so much other stuff that, like doing machine learning requires. And so, I mean, this is what like James Mickens at Harvard says, right? Like if you want to write Haskell, it does not sort of like run directly on top of x86. There's lots of other things that need to happen for machine learning to happen. And you might be very interested in those things. And like, it may all be sort of very interesting to you. So don't think about machine learning as sort of this one thing. It's sort of like, you can do machine learning and X, as Dean said, and that may be like really interesting to you.
Yeah, and there's another question on here as well that talks about having an interest in multiple fields, and having an interest in multiple fields is great, because a lot of times that's what makes you unique. Now the problem is when you apply to apply to PhD is by saying, I'm interested in computer architecture and Victorian music, right? May really limit the set of faculty that might want to work with you. But if you find the right person, they're going to say, I can't believe I found a student that has both these interests, right? And so it's but a lot of times your set of interests, right, is if you have multiple interests, is the thing that makes you most unique and most valuable. So I do want to end on time, and I want to respect everybody's time. And so let me just ask the panelists if they have any sort of last words that they want to share.
Actually, I was looking through my email, wasn't able to find it. So NSF had a program. I noticed that some of the questions were coming from maybe students that are considering being outside, being in industry for a little bit. So NSF has this program that provides funding to help bring students who have left undergrad or are in industry for some small number of years to come back and research. So there are some opportunities there that potentially can make an applicant lower risk if they're coming in with their own funding. I could not find the email to find the name of the program if anyone knows it, but it's an NSF program that was available earlier this year.
So I guess to speak to the original topic of what is research, I want to at least say one thing about what is the practice of research. Because we talked a bit about the sort of, the research aspect, but also sort of usually some degree of research engineering that tends to have to happen over the course of a PhD as well. And so I think you should be aware that even if, for instance, let me give a particular example, in computer architecture, you might think that's a pretty hardware-oriented field, and many of the problems we're facing in our solutions, benefit from an understanding of some of the physical realities of hardware. But you need to be spending, in general, a lot of time working with a multi-100,000 line piece of code called a simulator that you need to modify. So in terms of the skill sets that you're doing for research engineering, just be aware that, it's not all thinking. So even if, whether, and I want to try to see if I can try to spin this in a positive way. It is a benefit to you that if you have background in doing, right? Even doing things that are not your research per se, and partly the undergrad prepares you for that, but if you have industry experience as well in, say, even software development, right, that can actually be a good thing to understand in terms of how you're at least going to be able to get, the day job work of research done as well.
So thank you, everybody. I really want to thank our panelists. I want to just let the students know how shockingly easy it was to get volunteers to be on this panel. We were able to get some really prominent names in computer science research. Almost nobody said no. And because I think they believe that they'd really like to get the word out and help students make really informed decisions. I want to thank Steve Swanson. This was all his brainchild. And I want to thank Kasim Taram, who is behind the scenes making everything work today. So thank you. And panelists, I thank you for your time and your effort and your concern for students. And
thank you. It's been a pleasure.
That's all I've got. Thanks everybody for coming.
My pleasure.